Well, hi guys. I'm going to address some of the questions that you had last week. I asked you to put some challenging problems on at the end of your screencast assignment, and so I'm going to go ahead and address those problems. So one question was, how do you factor this polynomial? And the polynomial was 9x squared minus 36. Well, what I believe that page 154 was only referencing was that you always need to take out the greatest common factor no matter what. So step 1 to factoring is always take out the GCF no matter what. Because in this problem you could be tempted to do something else, because when you look at it, it fits the description of a difference of squares. But since the two terms have a greatest common factor, you're required to take that greatest common factor out first. So the greatest common factor of 9x squared and 36 is 9. We're going to take that 9 out first. So when you take the 9 out, 9 times what other factor will give you back 9x squared minus 36? Well, that's x squared minus 4. You see that you are not completely done, because x squared minus 4 is a difference of squares. So you must continue to factor completely. So at this point, we recognize that since the second factor was factorable, we must continue. So we have 9 times x plus 2 times x minus 2. Now, alternatively, if you did not recognize that 9x squared minus 36 contained a greatest common factor, and you saw that it fit the description of a difference of squares, okay, so this is, let me just emphasize this is the way I want you to do it, the way to the left. But let's say you didn't recognize that 9x squared minus 36 had a greatest common factor. Alternatively, you could have said that the answer was, okay, well, you could start off with saying square root of 9x squared is 3x, square root of 36 is 6, plus or minus. But look at this. Notice that there's also a common factor in each of these parentheses, so you're not done. So even if you did not recognize the GCF, you should be able to recognize now that in each parenthesis there's something in common. 3 is in common, so take the 3 out of the first parenthesis, you get x plus 2. Another 3 is in common for the second parenthesis, you'll get x minus 2, since that's 3x minus 6. I always check this, make sure that when you multiply at every stage you get back the previous factors or previous polynomial. Now look, now we have this 3 times this 3, which gives you that 9 that's right here. So if you recognize that you're haven't completely factored at this point, you still can get to the right answer, but most people forget or don't recognize when there's still a common factor in each of the parentheses. So that addresses that first problem. Okay, let's go to another problem. Alright, next someone wanted to know how to factor a sum of cubes. And here we have a cubes problem, 8a cubed plus 125b cubed. So the biggest thing here is the breakdown part, which I asked all of my students to do, is to first break down the 8a cubed plus 125b cubed into the a and the b, because the formula that I give you, and it's not universally, you don't have to use a and b, but the formula that's in our textbook, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So if you recognize that it is a sum of cubes, then we're just going to break down this problem so that it's something cubed plus something cubed. And that's going to, what goes in the parentheses is going to be our a and our b. So this is going to be our a, this is going to be our b. Once we realize that, we're just plugging in the a and the b following this pattern right here. So this is really the hardest part, is figuring out what is the a and the b in our case. Now, to find the a and the b that goes in the formula, all you're doing is finding the cube root of each term. A calculator can help you with that. What times itself will give you 8a cubed, or in other words, what is the cube root of 8a cubed? And it's 2a. What's the cube root of 125b cubed? It's 5b. So that's why for this formula here, we have a plus b times a squared minus a plus b squared. If you multiply that, believe it or not, you will only get a cubed plus b cubed. So we follow the formula because we see that it is a sum of cubes formula. So what is a in our case? A is 2a. Alright, then the formula says plus down here, plus. What is b in our case? B is 5b. Because we have to use what numbers will work out for our problem, 8a cubed plus 125b cubed, not a cubed plus b cubed. But if we break it down to what the cube root of 8a cubed is and the cube root of 125b cubed, then all we have to do is replace all of the a's and the b's with the a's and the b's we found. Alright, so let's go to the second parenthesis, square the a. And notice that a is not just a, it's also 2a. So if we squared a 2a, let me write that out. If you squared all of that, you get 4a squared minus, then multiply a times b. If you multiply 2a times 5b together, you get 10ab. And then you got to square your b. Well, our 5b is our b, so we got to square all of that, so we will get 25b squared. So your answer is 2a plus 5b times 4a squared minus 10ab plus 25b squared. You could check that by multiplying like so, multiplying all of that out to see if you get 8a cubed plus 125b cubed once you add all your like terms together. Alright. Let's go to the next question. Someone asked about a problem that says x plus 2 cubed. Now this is not a factoring problem. This is a multiplication problem. So for example, if you had, let's start with x plus 2 squared. Most people know what that is. They know that you must multiply x plus 2 times itself. So anytime you have an exponent here, you really need to write this twice and multiply. So even if I just gave you 5 squared right now, really you're just multiplying 5 times 5, for example. Now if I'm multiplying x plus 2 times x plus 2, we need to really go ahead and multiply or FOIL it, as we say. So that'll be x squared times, well, this x times 2 is 2x. Plus 2 times x is 2x, times 2 times 2 is 4. So that really gives you x squared plus 4x plus 4. Or, for example, 5 squared, you write 5 twice, that gives you 25. Now what is x plus 2 cubed equivalent to? Well, we'll write x plus 2 times x plus 2 times x plus 2, because really we're multiplying it times itself. We're writing it 3 times because of this exponent. If that was a 4, we'll write it 4 times and multiply. But since it's 3, we're just going to multiply x plus 2 times x plus 2 times x plus 2. Now, I just told you what x plus 2 times x plus 2 is, right? So what I recommend you do is just write x plus 2 down. That's the first one. Right. And I know what this is because I just did it. It's x squared plus 4x plus 4. So notice I had to multiply two things together first. Then I'm going to come back and multiply x times x squared. And you can use the stack method if you want. So let's try it. X times x squared is x cubed. X times 4 is 4x squared. X times 4 is 4x. Then you can come back. So whatever you have in this parenthesis, you have to multiply times the other parenthesis. We just multiply x times everything in the second parenthesis. Now we're going to come back and multiply 2 times everything in the second parenthesis. So 2 times x squared is 2x squared. 2 times 4x, 8x. And 2 times 4 is 8. So notice that I stacked them according to its like term so that it'll be more organized. And when you're be as organized as possible in math, it really does help you so you won't get overwhelmed with all of these terms. And so you notice now that I have my like terms under each other. I don't have to find them. I don't have to search for my like terms. So we have x cubed, just bring that down, plus 6x squared. Notice also we got, it just happens to be in descending order, so that's nice. 4x plus 8x, 12x plus 8. So that's how you multiply, okay? A binomial times another binomial times another binomial. So you take your time to multiply two binomials together. You know how to do that. That's foiling. Then you'll multiply the other binomial times your result. So please don't try to multiply 3 things at one time unless you know something like Pascal's triangle. But if you don't worry about it. Alright, one last problem. Alright, we have one problem which is 50 n to the 4 plus 123 n squared minus 5. Well, you should recognize that this is a trinomial because there are 3 terms here. So because it's what I call the other case, meaning that the leading coefficient is not 1, I will employ the AC method. So because I use the AC method, we're going to multiply 50 times -5, which is -250. And then we're trying to find factors of that -250 that will add up to 123. So I'm usually not concerned about signs at first. I'm just writing factors of 250 out. For example, 1 and 250. Then you go to 2 and you say 2 times what will give you 150. So 2 goes into 1 times. Then, of course, when I look at this 2 and 125, if I subtract those, I will get 123. And because I need my, because this sign is positive here, I know that my larger number needs to be positive. So I'm going to make the -2. And so if you recognize that you found the 2 factors, you don't have to exhaust the entire list. But if you're struggling with finding factors, it is best that you exhaust all of the possibilities and write them all down, list them all here, and then try to decide based on your knowledge of integer rules what will multiply to give you -250, but at the same time add to give you this middle coefficient. So we found it. We're going to expand the 3 terms to 4 terms. I'm just going to put -2 since it's first, but you could have put plus 125 n squared. I'm going to put n squared, obviously, because my middle terms must add up to 123 n squared. So if I don't have n squared on here, it's not going to add up to 123n squared. Then you're going to group. So 2n squared can be taken out. We have 25n squared minus 1 plus, you take 5 out. And what you want is, you want this to also apply over here. And so it does. So 5 times 25n squared will give you the 125n squared. And the negative 1 will give you that negative 5 here. So take out the GCF. The GCF is 25n squared minus 1. It just happens to be a common binomial factor. Then you must, when you take the GCF out, you're left with 2n squared plus 5. What most people don't see is that this is also a difference of squares. So you're not completely done. You have to factor that difference of squares. But remembering to keep the 2n squared plus 5. So square root of 25n squared is 5n. Square root of 1 is 1. And your signs should be plus minus. Again, as you probably heard in my previous videos and lectures, is that multiplication is commutative. So the order of these factors do not matter. If you multiply all of this together, you will get the 50n to the 4th plus 123n squared minus 5. Notice you got 5 times 5n times 5n times 2n squared. That'll be 25n squared times 2n squared. Right there you can see that gives you 50n to the 4th. And you can always multiply that out like the example that I did before, but you don't have to. If you're pretty confident about factoring, then you kind of get the feel or the sense when you're not doing something completely right. Alright, so just follow your gut on that. And I hope this helps.